Teacher.
Good morning, class. How are you?
Yeah, fine.
Okay, thanks. Sit down.
Thank you very much.
As you know, our unit is unit number 7. Yes. Archimede principles and atmospheric pressure.
Yes.
Pressure. Thanks. Who can read this story? Sylvestre, can you read?
Yes, Kamara was standing near the dam and tried to submerge a balloon into water, but the balloon kept rising upward. Question: why could the balloon not remain underwater?
Yes, in pairs. Answer this question. In 1 minute only. Now it's time.
Yes.
Okay, who can answer that question? Eric, can you answer that question?
The question was all about why could the balloon not remain underwater.
Yes.
I guess that the reason behind why the balloon didn't remain underwater is that there might be a force which is causing the balloon to rise up. That force is pushing the balloon to come up again above the water surface.
Okay, give him a flowers.
Flowers.
Okay, thanks. Others?
Another point.
Yeah.
The reason why the balloon not remain underwater means the mass of the balloon is less than the mass of water.
Mass of balloon
Is less than
Yes.
the volume of water.
Okay, thanks. According to our questions, and as our colleagues said, there is an upward force that pushing the ball to go up.
Yes.
You know?
Yes.
Now, who can expect the lesson we are going to study? Manuel, can you?
Floating or sinking.
Floating
Or sinking.
or sinking? Others? Peter, can you help us? Peter.
We are going to study lifting force.
Lifting force.
Lifting force.
Oh, that's amazing. Lifting force. Okay. Now, according to our colleagues, our lesson today is what is the upward force? What is the meaning of the upward force? What is the meaning of the force? The force. Here, who can read the lesson objective? We are going to. Yes, Gilbert.
Lesson objectives: by the end of the lesson, learners should be able to describe upthrust forces or buoyant force, identify factors affecting upthrust, state Archimede principle, and write the formula of upthrust.
Yes, thanks. Okay, I have some materials here. There you have the some materials. We have some balloons, 2 balloons, and then this group go there and go there. Here it is the water which is inside the bucket. Our mission is to submerge the balloon into water and observe what happened.
Yes.
Yes.
Let's do it. Yeah, it can't.
You see?
It can't see.
Now, let it. Let it. You see? You see?
Yes.
Okay. Go in your places. Based on your observation, you are going to answer those questions. Question 1 is what happened when the balloon was pushed into water? Second one, why did the balloon move upward after being released? Question 3 is what force do you think acts on object placed in water? Fourth one is how does water help some object to float? In pairs, do according to your observation.
Please, teacher, may I go out?
Okay, go. Two minutes only. Activity. We are going to present what your findings in your groups. Clear? Yes. Okay. Gilbert, can you answer question number 1?
Yes. It is asking about what happened when the balloon was pushed into water.
Into water.
Yes, the balloon resists to be underwater due to the forces, which is the upward force.
Upward force.
Yes.
Okay. Question 2. Who can answer question number 2? Peter, can you answer?
Yes. The question was why did the balloon move upward after being released?
Yes.
I think it's because as we are going to study upthrust force, I think is because that force.
Yes.
Water, the force from the water.
Yes.
Yeah.
Question number 3. Who can answer? Andy.
Yes, the question was, what force do you think acts on objects placed in the water? I think it's upward force because the balloon refused to remain into the water.
Yes, we can call the upward force as a buoyant force or up thrust force. Clear? Yes. Question 4. How does the water help some object to float? How? Gilbert, can you answer?
Yes. Water is that upthrust object. But remember, the process of floating occurs when the density of water is greater than the density of the object.
Yes. We can say our object will be float if and only if the weight of water,
Yes.
we have the object as, you can take object as our balloon.
Yes.
And then when you put the balloon in the bucket and you push into water and when they left it, our ball, it floats. Clear?
It floats.
Yes, it floats. We have a force. We have a force which exerts on our object. We have up plus the force, or balance force, or upward force, and weight.
Yes.
So our float will be float if and only if the weight of the density of the water is greater than the density of object. Thanks. We have
Let's explore it.
here we are going to study activity. We are going to do activity number 2.
Yes.
Wait. We are going to use the simulation.
Yes.
I think you are familiar with
Yes.
Yes.
It is a perfect simulation.
you are observing. If you have a question, you can ask me. We have here the object. We have our object. You see?
Yes.
And then we have a spring balance. We have a beam balance
Yes.
here. And then we have a beaker which accepts the water that will be displaced.
Yes.
Yeah. See, as you see, we have our object in the air.
Yes.
First, we can measure the weight of our object. We have our object. It has. Let's use the mass. Our object it has a 4 kilogram. It has a 4 kilogram, and then as you see, it has a weight which is equal to 39.2 newtons. You see?
Yes.
And when you put into water, our conditioning object will be submerged, means partially. When you put into water, the water will be up because we put something into water.
Yes.
As you see, our water or fluid will be displaced as 4 liters. You know, 1 liter is equal to 4 kilograms because our measurement, you see the fluid density is equal to 1.00 kilogram per liter. Means 1 liter is equal to 1 kilogram.
Yes.
Means the weight of fluid displaced is equal to 49.2 newtons.
Yes.
As you remember, when we find the weight of our object in the air before you put it inside the beaker, it's weight 39.2. We have weight in the air and then weight in water, and then it's measure 39.2 newtons. Clear?
Yeah.
Clear. Now, according to your observation, you are going to answer the following questions. Question 1, what happens to the upward force when a larger part of the object is submerged in water? Yes, Eric.
Force increase also.
Increase.
Yeah.
Because the amount of water will be increased.
Yeah.
Question 2, in the simulations, how does the weight of displaced water compare to the upward acting on the object? Mr. Wataka?
The weight of displaced water will be equal to the upthrust.
Give him flowers.
Flowers.
Now, we have, as you have been discussed, our colleagues said the weight of displaced water is equal to the upward force acting on the object. You can note something on the side. When you put the object in a fluid which is inside in our bucket, when you put the something, and then the weight of water becomes equal to the
To the weight of water.
Displace the water.
yes,
The weight.
the weight of displaced water is equal to the upward force.
Yes. To the force.
It means it verified the Archimede principle.
Yes.
Yes, thanks. It is said that when the object or body is totally or partially immersed in the fluid, it experiences in upward force or upward force or buoyant force equal to the weight of a fluid displaced.
Yes.
This is the Archimede principle.
Yes.
We have the worked examples. Do in your groups by using the Archimede principle. Force is equal to the, as you know, Archimede principle is said that when the weight of water is the Archimede principle said that the weight of water is equal to the upward force or buoyant force. Yes. It's equal to the weight of water displaced. And then buoyant force is equal to mg as the weight of water displaced. Means buoyant force is equal to mass is equal to the density times
Volume.
density times the volume of water displaced.
Yes.
You can use this formula or the buoyant force. You can call as the weight in air minus weight in water. That is formula you can use to solve
The problem.
this question.
Yes.
Do these examples in pairs
Yes.
by using the Archimede principle.
Yes, finish it.
Finish it.
Yes.
Finish it. Okay, thanks. You see this image? You try to observe this image.
Yes. Observing it.
Yes, we have the questions as you see. We have a boat which is float in the water.
Moving.
On the water, yes. Our question is why ships float on the water? But according to have been studied, why ships float on the water? Gilbert,
Ships float on water due to the density of water is greater than density of ships, or because of the upthrust force.
sure,
Yes,
sure.
more than sure.
Eric, Mr. Wataka, can you answer?
The ship float on the water because the force upthrust, the force exerted by the water to the ship will be equal to the weight of the ship.
Okay, give him flowers. Okay. Who can summarize? Before you summarize, you can see some factors that affect the upward force. The first one is the density.
Yes.
Yes. And the volume and the gravity of what? And the gravity and the acceleration due to gravity.
Yes.
And the depth of the immersion of the object in the fluid.
Yes.
And then, who can summarize the lesson you have learned today?
Yes.
Gilbert.
Yes. We have seen the upthrust force, which is also called buoyant force or upward force.
Yes.
We have seen the Archimedes principle, which states that when the body is completely or partially immerged,
Yes.
it experiences upthrust force. And also we have seen the factors which are acceleration due to gravity, density, and so on. Thank you.
And so on. Others? And then we have a homework here. Our homework, we have only two questions. The throwing mass in water. Calculate the upward force acting on the stone. And then we have a second one. You can write in your notebooks.
Yes.
And then this is our end of our lesson. If there is no problem, we can close here.
Yes.
Okay. Thanks. See you next.